Okay, let's look at question 6. Figure 8 shows a circuit diagram containing two identical lamps arranged in parallel. The reading on the ammeter is 186 milliamps. Milliamps. Milli means times 10 to the minus 3, like millimeters. It's 1,000th of an amp. Okay? Which statement about the current through the lamp is true? Tick one box. Right. Okay, so the current through both lamp P and Q is 0.093 amps. Look, it is not in milliamps anymore, so we need to think about converting that. Right, so it's 1,000th. Right, so we can times by 1,000. I think. Yeah. Anyway, so definitely this will become, you move the decimal place 3 times over. 1, 2, 3. So it becomes 0.186 amps. Right, so that's actually what the reading would be. So if I've got, let's just make the numbers easy. If I have 2 amps flowing down here, and then they have a choice, so some can go this way and some can go this way. Okay, assuming that both the lamps have identical resistance, you'll get 1 amp and 1 amp. In fact, the rule is whatever enters the node, so whatever's coming into the node will equal whatever's leaving the node. So if I've got 0.186 coming in, then I would expect half of it to be going each way. So if I get a calculator and divide 0.186 divided by 2, it comes out as 0.093. So I'd have 0.093 flowing this way, 0.093 flowing this way, and if I add that to that, it should add up to this. So that all makes sense. So I will say provisionally this is the correct one. I will just check that the rest don't make sense. Good exam technique. 0.186. Well, it was milliamps. 0.86 amps. So they've done the conversion correctly, but they haven't divided it as it splits. So it can't be that. 0.93 amps. Again, half of 0.186 is not 0.93, it's 0.093. So that's not right. And again, conversion has been done wrong there. So I'm happy that this is the correct answer. Okay, let's look at the next question. One of the lamps breaks and is not replaced. Which statement about the current in the other lamp is true? So we imagine that one of these lamps breaks. This wire is removed. Okay, so what's going on here? Right, well, the way series and parallel circuits work is that both these bulbs, let's say that was a 10 volt bulb, both these bulbs will have a potential difference of 10 volts across them. And Ohm's law, which is V equals IR, tells you that the current flowing I is equal to, so if you're not sure how to rearrange these formulas, you can use a triangle, but the current, I will divide both sides by R, so it'll be I over R. V over R. The current flowing depends on the voltage and the resistance, right, in that branch. The voltage across this would have been 10, so its resistance would have been whatever it was. Okay, so removing this bulb here will not change the voltage across bulb Q. So the current will stay the same. That's what we expect to happen. The current stays the same. Okay, figure 9 shows a circuit that can be used to alter the brightness of a lamp. The resistance of the variable resistor is increased. What effect will this have on the brightness of the lamp? Explain your answer. Okay, so I'm going to say if we make
if we increase the resistance of this resistor here, then it will take more of the energy. So the resistor is increased. So let's just get straight to what effect. Let's say that straight away for one of the marks. What effect? So the effect will be to make the bulb brighter, duller. That's one mark. Make the bulb duller, and then the Y. More energy is converted into heat. More electrical energy is converted into heat by the resistance. Three dots. Therefore, less available for the bulb. Okay, I'll check again the mark scheme at the end, but sometimes it can be quite tricky to make sure you get all the marks on a written answer.
So I will check, but that would be my best guess. Okay, next bit. When the potential difference across the lamp is 3.3 volts, the current is 0.15 amps. Write down an equation that links current, potential difference, and resistance. Okay, so the formula would be V equals IR.
I'm a brick! Hi, Lisa! Hi, Super Nintendo Chalmers! I'm lending! I eated the purple berries! How... oh...
How are they, Ralph? Good?
They taste like burning!
Calculate the resistance of the lamp. Okay, again, so if you're not sure how to rearrange these equations, I mean, I would just divide both sides by R, but let's do the standard procedure. Sub the numbers first. So write your formula. V equals IR. This is one of the ones you need to know. V is 3.3. I is 0.15, and R is what we need to find. Okay, so if you're not sure, you can use that. I need to rearrange for R, so it's V divided by I. So I'm going to do 3.3 over 0.15. 3.3 divided by 0.15 gets me 22 ohms. 22, and they give me the unit, so I should be fine. Okay, 3 marks available for us. Quite a straightforward calculation. Okay, next, sketch a current potential difference graph for a filament lamp. Okay, and that's the last question. So, a filament lamp behaves like a normal resistor. So a normal resistor looks like this, right? You make the voltage bigger, the current gets bigger. You make the voltage bigger, the current gets bigger. You make the voltage bigger, the current gets bigger. And it carries on like that, and the line is straight. It obeys Ohm's law. Voltage remains proportional to current, right? But a filament lamp, that doesn't happen. Initially, as voltage goes up, current goes up, right? But then, as the bulb gets hotter and hotter, and it's harder and harder to push current through it, it tails off. Now, you may have seen, you may have learnt these graphs like this. So you see them in reverse. If you reverse the voltage, say you say that's plus 1 volt, then this would be minus 1 volt. You get current flowing in the opposite direction, and if you reverse it and increase it a bit more, you get it in the flowing in the opposite direction, in the opposite direction, in the opposite direction, and you get a straight line like this for a resistor, right? But for a filament bulb, you've probably seen this, I and V, and you see this S-shaped curve. Whoops, and I should really be going through the center of the axis. Okay, and this graph is only asking you to just draw that part of it, hence it looks like that. Okay, I hope you found this useful. Thanks for watching. Please like, subscribe and share.